Hello, good morning, good afternoon, and good evening. Our topic for today is investigation of concentric footing with or without moments based on NSCP 2015. So let's start with the figure. Ang dimension ng column you have here C1 and C2. C1 being the dimension along X, and then C2 yung dimension along Y. Tapos, itong bar diameter, this is the rebars of the column. And then, pieces. Minimum here is 4 pieces. And then, ang diameter ng columns ay 16 mm ang minimum. And then, there is a provision here. Use bars as dowels. Always, yes. Dahil yung column rebars ay ganito. Yan. So, magle-letter L yan. Nakapatong itong column rebars dito sa bakal ng footing. Kaya, yes palagi yan. And then, for the footing dimensions, B is the dimension along Y, and then length is the dimension along X. And take note that L, for this pattern, L should always be greater than B. Okay? And then the thickness T, ito siya. Tapos, DF is the from the base of the footing up to the top of soil. Or this is known as the depth of excavation. And then we have concrete F prime C. Then steel Fy. Ang steel Fy pertains to the strength of your footing rebars. And then longitudinal bars at bottom, yes or no. This is always yes. So, mauunang ibinababa yung longitudinal bars, and then on top of that is the transverse bars. Ito, yan. This is known as DBY. Ito, yan. Nakatayo. And then, itong horizontal, this is DBX. Mas mababa yung effective depth nito in the sense na mas malaki ang moment Y compared sa moment X. So, pag mas malaki, mas mataas ang effective depth, mas mataas ang moment capacity. And then, you also have NX, or the number of pieces of diameter bars. And then transverse bars, and then NY. And then we have the moments. Meron tayong dead, live, wind, and then earthquake. This is, ang axis nito ay yung x-axis. Ito. So this is moment X. So ang bakal na magre-resist ng MX is yung DBY. And then, yung moment Y or moment load along Y-axis, ang magre-resist ng moment na yan ay yung mga bakal ng DBX. So, obviously, pag ganito ang layout natin, L is greater than B, ang moment Y ay obviously mas malaki compared sa MX. So, yan ang orientation natin. And then, para dito naman sa moment load along x-axis, so ito ang moment natin, x. Ang direction ng earthquake is in y direction. Kaya, ang earthquake dito, paganyan. Okay? Ang maapektuhang moment is mx. Kapag ang moment natin in the x direction, ang moment in consideration is obviously the my. Now, let's go to the soil properties. Yung soil weight, unit weight of soil, bibigay ito nung soil bearing report, and then factor of safety, usually 3, and then allowable soil bearing capacity, and then the surcharge Q sub S. Ito yung mga load na nakapatong sa ibabaw ng lupa. Pwede itong floor slab. And then, consider weight of soil, yes or no. kung minsan ginagamit ko dyan, yes. And then dito, meron tayong dowel diameter, tsaka number of pieces. Meron 3 asterisks dito. So, ito yun. Use bars as dowels, yes or no. Kapag ang answer mo dito ay no, then that's the time na i-consider natin yung diameter of itong dowel bars. Okay, next. Ito naman, longitudinal temperature and shrinkage bars. Ito yung mga bakal na nandito sa ibabaw, sa taas. Okay, yan. Dito sa ilalim, ito yung mga reinforcing steel bars. So, meron tayong longitudinal. So, that is in the X direction also. Katapat niya yung longitudinal bars. At meron din tayong transverse temperature and shrinkage bars. Also, you have here NTX or NTY. And then, other considerations, you have the unit weight of concrete, and then clear cover is always 75 mm. This is directly cast to earth. Ibig sabihin, ibinuhos ka agad yung concrete sa lupa at walang forma. So, yan ang 75 mm. And then, we have axial loads, that is yung P. So, if you will add all these axial loads, that will become summation P. Then, we have the load combinations based on NSCP 203.4.2. We have 1.4D, 1.2 dead plus 1.6L, up to dead load plus 0.7143 times E 203-18. And then, 1.4D plus 1.7, ito yung old code. This is optional. And then, dito tayo ngayon sa summation P. This is equal to the sum of P dead, P live, P wind, and P earthquake, summation moment X. That is the sum of moment X dead, live, wind, and earthquake. And then summation moment Y, yung sum naman ng moment Y for dead, live, wind, and earthquake. And then we have PU. So, sa PU, gagamitin mo itong mga equations na yan, and ganoon din sa MUX tsaka sa MUY. And then we have here the basic reinforced concrete design for singly reinforced beam. Okay, for F prime C lesser than equal to or lesser than 28, your beta factor is 0.85. Ngayon, kapag ang F prime C mo is greater than 28, ito na ang bago mong beta factor. And then, rho minimum is the maximum of these two equations. And then, rho max is ito. You have two equations for rho max. Ito, 0.75 rho balance, tsaka itong may 3 all over 7. Next. The depth of longitudinal reinforcing steel bars. So, ang kukunin nating depth ay ito, yan, dbx. So, ito yung nasa ilalim na bakal. So, let's say, ito siya, yung line na yan. And then, kukunin natin itong effective depth from the top. So, that is equal to the thickness T minus the clear cover, which is 75, minus dbx all over 2. Or, kapag ang sagot mo dito ay no, longitudinal bars at bottom, no, then magpapalit ang equation natin dito sa dx. So, magiging, ibig sabihin yan, yung longitudinal bars natin, nandun na sa taas. Okay? So, magiging T minus clear cover since nasa taas na nasa ibabaw ni dby si dbx, so magiging t minus clear cover minus dby minus dbx all over. Kaya mapapansin nyo dito sa question na yan, meron tayong single asterisk. This refers to this question. Yan. And then, balik tayo dito ngayon naman sa depth of transverse RSB or dy. So, ito yung mga parang bars along y. So, that is t minus clear cover minus dbx minus dby all over 2. So, mapapansin nyo na ito ay nasa ibabaw ni dbx. Again, pag ang sagot mo dun sa question kanina, kapag no, ito naman ang gagamitin mong equation. From basic mechanics, stress is equal, or F is equal to mc all over I, where m is the moment, and then c, that is the depth all over 2, and then I is the moment of inertia. I think this is bh cubed all over 12. Let's say here we have a rectangular section wherein h is the height, b is the width. Then this is the neutral axis. So c is equal to h over 2, and then I is 112 bh cubed. Ayan siya. So, the stress is equal to mh, okay, wherein c is equal to h over 2. So, we substituted this equation here. So, ang stress natin will boil down to 6m all over bh squared. Now, we apply this stress equation para dito sa mx. Okay, so yung para dito sa mx, yung b ngayon magiging L, tapos yung h magiging capital B. So we will substitute. So your stress now becomes 6 times mx all over LB squared. So we simply substituted capital B and L dito. And likewise, kung dito naman sa my, stress now will become 6my. Ito ngayon ang dimension B will now become your dimension small b. Tapos itong dimension L, yan yung maging dimension H. So again, substituting this, replacing these characters here with capital B and L, itong magiging equation natin. So, stress is equal to 6my all over BL squared. So, magpapansin nyo na nagbaliktad lang ito. Nasa denominator, ito BL squared, ito naman LB squared. So, ang kailangan natin dito ay yung my tsaka yung mx. Probably in the terms of summation moment and ultimate moment. In the design of footing, meron tayong 12 checks. We have number 1 is the check for footing dimension, and then number 2, soil pressure at service loads, and then 3, check ultimate pressure, tapos 4, check for punching or two-way shear, napagbaliktad ko lang dito. Itong check punching shear, this is 4 dito sa spreadsheet. And then next, beam or one-way shear. Ito yan. Tapos, number 6, check weight of footing. Then 7, checking of reinforcing steel bars. Tapos 8, you have checking for bandwidth. And then 9, temperature and shrinkage bars, or ito na yung top bars. Tapos 10, you have check for bearing connection. Dito na papasok yung mga dowel bars natin. And then 11, check for development length and clear bar spacing. And finally, number 12, check soil bearing pressure. Dito na papasok yung mga factor of safety natin. So, before proceeding to check number 1, kailangan tama yung ating mga forces. And those forces includes yung summation P and then PU, summation moment, and then ultimate moments. So, let's take a sample here with moments. Ayan. Also with earthquake loads. So, before going to check number 1, kunin muna natin yung summation ng P, which is equal to 3190. So, you just add all those. Ganun din sa MX. You just add those moments. Same with MY. Take note na itong mga pula, yan ay input data. And then, let's get ultimate axial load or PU. We will apply these equations 1.4D. So, ito. For equation 1.4D, that is equal to 1.4 times 1800. Ito yon. And then, itong 1.2D plus 1.6L, so that is equal to 1.2 times dead plus 1.6 times live. That is equal to 4160. So, sundan mo lahat yan hanggang sa 1.4D plus 1.7L. Ngayon, dito 0 dahil naglagay ako dito ng question ng consider 1.4D plus 1.7L. Kapag nilagay ko yes, magko-compute siya. Yan. And then, i-consider ngayon ni PU yung maximum dito. Okay? So, kapag ginawa ko tong, no, see what happens. Sorry. Yan. Sorry. No. Nagpapalit ito. 4160 kapag no. Kapag yes, nagiging 4645. So, which is conservative? 4645 or no? Yan. See? Okay, next. So, same pattern. Ganon din sa MX. And then sa MY. So, si PU, hahanapin niya yung maximum dito. Ganon din si MX. Si MUX, hanapin niya yung maximum dyan. Ganon din kay MUY, maximum. So, kapag consider 1.4, yes, there is a possibility na magpalit yung MX, tsaka MY, tsaka yung PU. Okay? After that, kukunin natin si effective soil pressure Q sub E, ito, which is equal to QA minus unit weight concrete T minus unit weight of soil times dF minus T minus QS. Now, how did we arrive to this equation? Itong allowable soil pressure Q sub A, ang nagbibigay nito ay si Geotechnical Soil Report, yung mga gumagawa ng boring test. And then, ang nagbibigay din ng unit weight ng soil ay si Geotechnical Engineer. Tapos, ang ibig sabihin naman ng effective soil pressure, ito yung soil pressure na nasa ilalim na mismo nung in contact with the footing, yung nandito na sa ilalim. So, in short, yung soil pressure dito sa ilalim, tatanggalin, i-consider natin ngayon yung mga pressures na nandun sa ibabaw. So, that includes now the surcharge, Q sub S, that includes also the soil above the footing, which is this, and obviously your footing mismo. Okay? And then, yung effective na yun yung re-resist ng P tsaka moments. Kaya ito siya. So, let us compute manually. Okay? However, dito sa ating spreadsheet, walang Q sub A or allowable soil pressure. Instead, ang binigay ngayon ay yung ultimate soil bearing capacity Q sub U. Take note that ultimate is equal to allowable all over, ultimate is equal to allowable times factor of safety, or this is equal to Q sub U is equal to Q sub A times factor of safety. So, ayan siya. So, ang kailangan natin dito ngayon ay si Q sub A now becomes Q sub U divided by factor of safety. So, that is now equal to Q sub U 600 divided by factor of safety na 3, which becomes now 200 kPa. Ito siya. Okay? Next, unit weight of concrete, or that is the density of concrete, 23.54. And then yung T, the thickness is, ito siya, 0.9, capital T. Dito sa spreadsheet ko, sa sample is capital T. Pero dito sa figure, I think this is small t. Okay lang yan. And then, eto siya. So, that is 0.9. Yan. And then, next na ima-minus natin ay yung soil. Ang i-consider natin na soil ay yung nasa ibabaw nito footing. So, that is unit weight of soil times the thickness of the soil layer, which boils down to this equation. Yan. Or that is equal to unit weight of soil, ito, times the quantity, depth of excavation, which is 1.5, minus the thickness of footing, then execute, or that is 10.8. Tapos yung kinompute natin kanina, unit weight of concrete times thickness T, ayan. Tapos, eto na, surcharge. Yung ating surcharge is lahat ng loads na nandito sa ibabaw ng footing, Q sub S. Kaya, meron tayong, anong mga surcharge natin? Meron tayong slab thickness. Take note na hindi ito yung footing, ha. Ito yung slab. Tapos, meron tayong floor load. Ayan. So, pag-a-addin natin yung dalawang yan. So, that is equal to slab thickness multiplied by the unit weight of concrete. Since this is in millimeter, i-divide natin yan ng 1,000. Tapos, i-add natin ngayon itong si floor load. So, plus 5. And that is 8.53. Ayan. Si surcharge Q sub S. Ngayon, ima-minus na natin silang tatlo kay Q sub A. Ito. So, ayan. Unit weight concrete T. Ayan si 21.2. And then, unit weight soil times DF minus T. Yan si 10.8. And then, Q sub S. Yan si 8.53. Okay, so that is now equal to 200 minus 21.2 minus 10.8 minus 8.53. Ulitin ko itong unit weight of soil times df minus t. So this is equal to unit weight of soil times the quantity df, so that is the depth of excavation, yan, 2.4 minus 0.9, yan, then close. And then ito na, ulitin na natin, equal to 200 minus yung unit weight concrete T minus 27 minus the surcharge is equal to 143 point something. Yan, 143.3, which is equal to this one. Okay? Now, let us compute your soil pressure Q, or that is your soil pressure based on your loads. So that is now considering summation P all over BL. Take note that pressure is equal to force all over area. Ngayon, ang force natin is summation P all over BL. Okay, so una nating solving si summation P all over BL. So, ito siya, divided by B times L. Okay, then close. Next, meron tayong moments, kaya sosolvin natin ito. Itong equation na yan, nanggaling yan dito sa, yan. Okay? So, 6mx all over lb squared. Ito yan. So, yung mx, palitan natin to ng summation mx. Tapos yung my, palitan natin ng summation my. So, this becomes now, yan. Take note na ito ay absolute values ang ginamit ko. Kasi, ang footing natin ay concentric or nasa gitna. So, ito ang una nating sosolving. So, is equal to 6 times summation moment x. Ito. Divided by L times B times B. Then, close. Next, let us compute itong part na yan. So, that is equal to 6 times summation moment y, ito, divided by b times L squared. Tapos, i-add na natin yung tatlong yan. So, that is now equal to your actual soil pressure. So, this is equal to 127.2 plus 10.39 plus 5.26 is equal to 142.8. Okay. So, eto yon, 142.84. So, ibobold ko yan. Ibig sabihin, na-solve na natin. So, now, we will compare these two. Okay? Your Q effective is equal to 143.28. And then, your Q, or actual soil pressure, is 142.84. So, Q sub E is greater than 142.84. Therefore, our footing is safe. So, yan ang ating unang check. However, this is not considering orthogonality effects. Ang orthogonality effects is you are considering 30% of the earthquake forces from the other direction. Now, consider naman natin yung orthogonality effects to compute your soil pressure Q. So, consider natin yung 30% ng earthquake in the other direction, which is this equation. So, let's say we have earthquake acting in the x direction. Okay, so EQ in the x. So, meron tayong, first, we have here the summation P all over BL. Ayan, summation P all over the quantity B times L. Tapos, yung equation na 6, kapag ang direction natin ay EQX, okay? So, ang gagamitin natin ay 6my all over BL squared, okay? 6my all over BL squared. Ayan. So, that is equal to 6 times summation my, which is ito, all over B times L times L. Yan yung 100%. Tapos, yung 30% naman ngayon, so ito yung 0.3 times 6mx all over L B squared. Yan naman yun. So, that is equal to 0.3 times 6 times summation moment x, ito, divided by the quantity L times B, then close. So, ito yung sinolve natin. Considering orthogonality effects. Yan. Okay? 6my and then 0.3 of summation mx. So now we will add all these 3. So that is equal to 127 plus 5 plus 3, 135.56523. Pero, yan yung earthquake acting in the x direction. So, how about the earthquake acting in the y direction? Para sa earthquake acting in the y direction, ang sosolving natin ngayon ay ito, 6 moment x all over LB squared, tsaka 30% nung my naman. So, ayan, palitan lang natin to ng x, tapos LB square, ito naman, palitan lang natin to ng y, and then BL squared. Okay, so is equal to 6 times mx all over L times B, and then close. Tapos, ito naman, 0.3 times 6 times my divided by B times L, and then close. And then, we will add, dito na tayo, yung tatlong yan, summation P, ito, tsaka yan. Ang summation P natin is, ayan, sinolve na natin kanina, plus this, plus that, is equal to 139. Ngayon, kukunin mo yung maximum dyan sa dalawa. Okay? At yun yung magiging critical. So, ang maximum dyan sa dalawa ngayon ay syempre si 139. So, maximum of this and that is equal to 139. Ito ngayon yung magiging soil pressure natin if considering orthogonality effects. So, ngayon, check na natin, palitan natin to ng y, dapat magiging 139 yan. So, y, yung, see, 139.16. So, that's how to check your soil pressure, your footing dimension, considering orthogonality effects. Ngayon, bakit footing dimension? Paano kung yung footing natin ay maliit? For example, ayan, ito naging 3.5. So, delete ko na yan. Let's say 3 meters by 4. Yan. Okay? So, fail na siya. Okay? So, yan yun. So, pag meron kang spreadsheet, dito ka na lang magpapalit. Hindi ka na mag-compute dito.